The stars scream at us from across an abyss so vast, our minds buckle. Alpha Centauri, our nearest stellar neighbor, is still an agonizing 4.3 light-years away. Our most powerful chemical rockets, they're cosmic toddlers, crawling across a football field that stretches for eons. Reaching even that first star would take tens of thousands of years. This isn't exploration. It's an agonizing, generational crawl. We are trapped. But what if there was a whisper from the quantum foam? A forbidden secret of the cosmos itself? A power so immense, it promised not just to bridge the void, but to shatter our very concept of speed. A single gram could unleash the energy of 1,000 atomic bombs. We're talking about antimatter, the ultimate key to the galaxy, yet a substance so volatile, so eager to annihilate, that merely touching it would rip reality apart. Can humanity ever truly harness pure oblivion? This is where the universe, in its infinite, baffling wisdom, offers a cheat code, a hidden power that laughs at those walls. It's called annihilation. Imagine, not a chemical reaction, where atoms merely rearrange, grudgingly releasing a tiny fraction of their stored potential. That's like lighting a single match in the heart of a cosmic winter. No, we're talking about something far more profound, something that fundamentally redefines the very concept of fuel. We're talking about matter meeting its exact opposite, a dance of death where every particle, every electron, every proton, every neutron finds its perfect mirror image nemesis, a positron, an antiproton, an antineutron. And then, poof, they don't just react, they vanish. Every single speck of their mass, every last iota, explodes into pure unadulterated energy. Not a fraction, not a percentage, 100% conversion. This is Einstein's E and MC2 ripped wide open, bleeding raw power, the very fabric of existence screaming as it transforms itself into a tidal wave of pure light and exotic particles. It is the ultimate expression of cosmic violence and cosmic efficiency. Think about the fuels we struggle with now. A pound of TNT, enough to blow up a small shed, a pathetic pop in the cosmic silence. A pound of enriched uranium in a fission reactor, enough to power a city for a day, or unleash the destructive force of a Hiroshima bomb, a mere flicker against the backdrop of a supernova. Now listen closely, because this is where your mind detonates, where the true terrifying potential of the universe reveals itself. A single pound of antimatter, colliding with a single pound of ordinary matter, would unleash the energy equivalent of 100 million tons of TNT. That's not a number you casually toss around. That's the equivalent of thousands of the most devastating nuclear weapons ever conceived, all firing at once. From 2 pounds of material, it's the energy output of the sun for an entire week, compressed into something you could hold in your hand. A cosmic credit card with an unlimited balance. This is energy density that defies human comprehension, a power source that makes nuclear fusion look like a flickering candle. This isn't merely efficient, it's the very scream of creation in reverse, the echo of the Big Bang itself contained in a whisper. It's the ultimate, most concentrated form of energy release known to physics, the theoretical maximum possible. And it is why antimatter isn't just as a solution for interstellar travel. It's the only angular solution. For us to truly breach the interstellar void, to accelerate a spacecraft to a significant fraction of the speed of light, not 0.1%, but 10%, 20%, even 50%, you need an exhaust velocity that approaches light speed itself, because at those speeds, time itself begins to bend. What takes generations for a conventional rocket becomes a mere decade or two for the crew, a feasible mission, a human lifespan, and only antimatter annihilation produces the kind of ultra-energetic gamma rays and charged particles capable of delivering that kind of sustained, relentless cosmic kick. Every other propulsion concept, every ion drive, every fusion torch pales into insignificance next to the raw, unbridled power of controlled annihilation. They are like rowboats attempting to cross an ocean, while antimatter is a warp drive, a shortcut woven into the very laws of physics. Imagine a starship, not creeping along, but surging. Each microgram of antimatter meticulously annihilated in a controlled magnetic field, unleashing a focused, directed beam of pure energy a tidal wave of thrust that devours the void behind you, propelling you faster and faster, bending space and time to your will. This isn't about burning fuel. It's about unmaking existence, transforming mass into momentum to propel you across the cosmos. It's the universe's most brutal, most beautiful secret, waiting to be unlocked. The prize? The stars themselves. No longer glittering impossibilities, but destinations within reach. The galaxy, once an unreachable dream, becomes our backyard. It's the ultimate gambit, the most audacious bet humanity could ever place against the crushing indifference of cosmic scale. But to even dream of this power, to even whisper its name, we must first learn to tame pure destruction. So, we crave this impossible power, this annihilation drive. But first, a chilling truth. Antimatter doesn't just exist out there, shimmering in vast cosmic reserves, waiting for us to scoop it up like stardust. No, the universe, in its cosmic cruelty, ensures that every single atom of antimatter we need, we must create. We must forge it, particle by agonizing particle from pure energy. It's like trying to turn sunlight into solid gold, only infinitely harder, infinitely more expensive, and infinitely more frustrating. Our current method, it's a testament to human audacity and desperation. We build monstrous machines, the largest, most complex instruments ever conceived by humanity. Think of CERN's Large Hadron Collider or Fermilab's Tevatron, not just as scientific instruments, but as cosmic forges. Straining at the very limits of physics, we hurl ordinary matter, protons, electrons, at each other at velocities so close to the speed of light, their very existence warps. We smash them together with more energy than a freight train at full speed. And what's the goal of this colossal violent ballet? To produce, for the briefest, most fleeting instant, the very conditions of the Big Bang itself. We are, in essence, trying to recreate the primordial chaos, hoping that in the maelstrom of these hyper-energetic collisions, a tiny, infinitesimal fraction of the unleashed energy will spontaneously solidify into an antimatter particle. It's a process of unimaginable inefficiency. For every billion, every trillion proton-on-proton collisions, we might, if the cosmic dice roll just right, get one single antiproton, one, out of a storm of subatomic debris. Think of it, you're trying to find a specific grain of sand on 1,000 beaches, but your only tool is a sledgehammer, and every swing generates a hurricane of irrelevant dust. The sheer energy required to accelerate these particles, to cool them, to guide them, to smash them, to then painstakingly separate the minuscule antiparticles from the torrential spray of normal matter, is mind-boggling. It takes gigawatts of electricity, enough to power a small city, running constantly, just to produce a few nanograms. A nanogram, that's a billionth of a gram. It's a quantity so small, it's practically theoretical, and the cost? Astronomical. Literally. We're talking billions of dollars invested over decades. The entire antimatter ever produced by humanity, painstakingly collected at facilities like CERN, amounts to less than 20 nanograms. That's enough to boil a few teacups of water. To send a small robotic probe to Alpha Centauri at just 10% the speed of light, we would need roughly 1,000 tons of antimatter. Nakong, not nanograms, tons. The gap between what we have and what we need isn't just a chasm, it's an intergalactic void in itself. To produce that much antimatter, at our current rates, would take literally billions of years. Billions. Longer than the universe has even existed. It's the ultimate energy crisis, a cosmic bottleneck that threatens to forever shackle us to our pale blue dot. This is the brutal reality of our cosmic ambition. We've glimpsed the ultimate power, but we are nowhere near mastering its creation. It's an uphill battle against the very laws of thermodynamics, a desperate gamble against the universe's stubborn refusal to yield its deepest secrets easily. This isn't just a technological hurdle, it's a fundamental challenge to our understanding of energy, matter, and the very fabric of existence. Can we truly bend these cosmic rules to our will? Can we invent a new way to conjure this forbidden fuel from the void? If this cosmic chase, this insane, relentless pursuit of the impossible, sparks something in your own mind, if you're as obsessed with breaching the void as I am, then smash that like button and subscribe. Join our growing crew of cosmic strategists, because the journey is just getting started and you won't want to miss the next mind-bending revelation. So let's say, against all odds, we've managed the impossible. We've spent millennia, harnessed entire stars, perhaps even twisted quantum mechanics to our will, and somehow we've created enough antimatter to fuel our dreams. We have our precious shimmering grams of cosmic oblivion. Now comes the truly terrifying part. How do you hold it? Think of it this way. Antimatter is the ultimate cosmic allergen. It is violently, fundamentally incompatible with everything we know, everything we are. Your ship, your crew, the very air you breathe. It's all ordinary matter. And if even a single antiproton, a solitary positron, so much as grazes a single atom of your ship's hull or a stray molecule of air, the result isn't a spark. It's not a chemical burn. It's a localized, instantaneous, hyper-energetic BLT detonation, a miniature Big Bang, right there inside your fuel tank. A tiny, perfect explosion, converting mass to energy, unleashing gamma rays and high-energy particles that would rip through your vessel like a cosmic shredder, vaporizing crew, melting systems, and potentially triggering a catastrophic chain reaction that would reduce your interstellar dream to a puff of radioactive plasma. This isn't a problem of engineering. It's a problem of our absolute containment. Nabiyan, you cannot touch it. You cannot let it touch anything. It is the purest form of destructive potential, constantly seeking its mirrored opposite, constantly yearning for annihilation. So, what's the cosmic strategist's desperate gambit? We turn to the only force in the universe that can hold something without touching it: magnetic fields. Imagine a cosmic cage, not of steel, but of invisible pulsating forces. This is the concept of a magnetic bottle or a penning trap. At its core, it exploits the fundamental properties of charged particles. Antiprotons, like protons, have a positive charge. Positrons, like electrons, have a negative charge. In theory, you can use exquisitely shaped, super strong magnetic fields to create a force field that repels these charged particles, literally levitating them in a perfect vacuum. Far from any matter, the antimatter would be suspended, a ghostly, glowing speck, floating in the dead center of its magnetic prison, never touching the walls. But this isn't some simple refrigerator magnet. We're talking about superconducting magnets, supercooled to near absolute zero, generating fields so powerful they could crush a tank. And even with these titanic forces, the challenge is immense. The antimatter particles are tiny, constantly jiggling, constantly trying to escape their invisible bonds. Any slight fluctuation in the magnetic field, any minute power failure, any unexpected jolt to the system, and your precious, ultra-expensive, civilization-defining fuel could instantly make contact with the containment vessel. Game over. Think of the precision required. The magnetic fields must be flawless, perfectly balanced, symmetrical to an unimaginable degree. The vacuum inside the containment vessel must be the most perfect vacuum humanity has ever created, far beyond anything achievable on Earth, because even a single stray atom of hydrogen gas could trigger a local annihilation. The temperature must be kept at the lowest possible extreme, because even the slightest thermal energy would cause the antiparticles to jiggle more violently, increasing their chances of escape. We're not just building a container, we're building a cosmic fortress of pure energy, designed to hold something that fundamentally wants to cease existing. And the scale for a starship? You're not talking about holding a few nanograms in a laboratory. You're talking about tons of this stuff, potentially in a liquid or solid state, all suspended, all perfectly isolated for years, even decades, of interstellar travel. The sheer volume of magnetic fields, the cryogenics, the redundant power systems, the sensors monitoring every single antiparticle's position with atomic precision. It's an engineering nightmare on a cosmic scale. A single stray cosmic ray, a tiny micrometeorite, a solar flare, any of these could perturb the delicate balance, leading to the ultimate catastrophic failure. This isn't just a technical challenge, it's a philosophical one. We are trying to impose absolute order on something that embodies ultimate chaos. We are attempting to build a perfect prison for pure destruction. The storage problem isn't just a hurdle, it's a gaping maw, a cosmic trap that could devour our interstellar ambitions before they even leave the launch pad. It's a testament to the fact that the universe doesn't easily yield its ultimate powers. It demands absolute mastery, absolute perfection, or it will simply, violently, erase your attempt from existence. So, if we've somehow defied cosmic odds, if we've created mountains of antimatter and then with godlike precision, trapped it in an unbreakable magnetic cage, now comes the ultimate engineering challenge. How do you actually use this pure destruction for propulsion? This isn't about igniting a flame. It's about controlled annihilation, a precise microsurgical detonation of reality itself. The goal? To direct the unimaginable energy release from matter-antimatter annihilation into a focused beam of thrust, propelling a starship to a significant fraction of the speed of light. Forget inefficient chemical rockets that spew hot gas. We need something that approaches the theoretical limit of exhaust velocity, the speed of light itself, and only pure energy in the form of gamma rays and high-energy particles can deliver that kind of kick. One of the most compelling theoretical designs is the antimatter beam core rocket. Imagine a tiny, almost microscopic core of antimatter, say liquid antihydrogen, suspended in the very heart of the engine by those impossible magnetic fields. Around this core, a stream of ordinary matter, perhaps hydrogen gas, is continuously injected. The magic happens at the interface. A controlled, steady stream of antimatter is allowed to annihilate with the ordinary hydrogen, microgram by microgram, in a meticulously controlled explosion. This is not a single catastrophic burst. It's a sustained, powerful roar. The annihilation produces a torrent of ultra-energetic gamma rays and highly charged pions, subatomic particles. These particles are then directed by powerful magnetic nozzles, essentially magnetic funnels, that shape and accelerate the plasma exhaust to incredible velocities. Think of it like a cosmic fire hose, but instead of water, it's spraying pure, raw energy. The challenge? Gamma rays are incredibly penetrating. They don't interact easily with matter. This means shielding the crew from this lethal radiation becomes an immense problem. You'd need vast amounts of dense material, perhaps even a magnetic shield that deflects the charged particles, making the ship incredibly massive. It's a race against radiation poisoning, a constant battle to protect life from the very power source that enables its journey. Another concept is the pulsed antimatter rocket. Instead of a continuous stream, imagine tiny, precisely measured pellets of antimatter and matter injected into a reaction chamber and annihilated in rapid controlled pulses. Each pulse creates a miniature explosion, pushing against a magnetic pusher plate at the rear of the ship, much like the Orion nuclear pulse propulsion concept, but with far greater efficiency. This would result in a series of incredibly powerful, rhythmic kicks, accelerating the ship with brutal efficiency. The advantage here is potentially less continuous radiation exposure, but the mechanical stress on the ship from these constant violent pulses would be immense. You're essentially riding a controlled internal explosion constantly. Then there's the antimatter sail, Nadula, a more futuristic, less direct approach. Here, antimatter isn't used as direct thrust, but as an incredibly efficient power source for a laser array. A tiny amount of antimatter annihilation generates enough power to fire a massive laser beam at a giant, ultra-thin light sail kilometers across. The photons from the laser striking the sail provide the propulsion. This sidesteps the direct handling of massive amounts of antimatter in a thrust chamber, but requires an external power source, the laser array on Earth or in orbit, and an impossibly large, durable sail that can withstand years of laser bombardment. It's a slower, but perhaps safer approach. No matter the design, the fundamental engineering chasm remains one toward precision control. Annihilation is inherently violent. To harness it for thrust, you need to control it at a level of precision that makes brain surgery look like blunt force trauma. Every microgram must be annihilated exactly when and where you want it. 2. Radiation shielding. Gamma rays are insidious. They go through almost anything. Protecting a living crew from a constant, high-energy gamma ray flux for years is a problem we haven't even begun to solve. It would require materials science breakthroughs that currently exist only in speculative physics. 3. Heat management. Converting mass to energy generates unimaginable heat. Dissipating that heat or channeling it for thrust without melting your entire ship is another monumental hurdle. You're trying to contain a miniature star in your engine. These aren't just minor kinks. They are fundamental barriers that require breakthroughs on the scale of discovering quantum mechanics itself. We are talking about building a machine that can perfectly control the most destructive force in the universe, protect fragile biological life from its raw fury, and sustain that operation for decades. It's a blueprint for the impossible, a dream whispered on the edge of oblivion. We have the cosmic vision, the raw, unbridled ambition, but the road from concept to cosmic reality is paved with engineering nightmares and physics puzzles that scream their defiance. It is the ultimate test of human ingenuity against the universe's most formidable secrets. So, here we are, staring into the heart of the antimatter paradox. It is the universe's most exquisite, most brutal joke, the very key to our cosmic freedom. The only plausible path to touch the distant stars within a human lifetime is also the purest distillation of destruction. It is the promise of infinite horizons wrapped in the threat of instant oblivion. We, humanity, stand at a precipice. On one side, the crushing indifference of the void, mocking our chemical rockets, ensuring our eternal confinement to this single fragile world. On the other, the terrifying allure of antimatter. It offers a future where we are no longer bound by light years, where the galaxy itself becomes our oyster. But to grasp that future, we must first master the art of creating the uncreatable and containing the uncontainable. We must learn to cradle pure annihilation, to harness the very essence of cosmic unmaking, and direct it with a precision that borders on the divine. This isn't just a tale of technology. It's a testament to our insatiable, almost reckless, drive to push beyond boundaries. It's the human spirit, defiant and unyielding, attempting to bend the most fundamental laws of physics to its will. The antimatter engine is more than a propulsion system. It's a cosmic mirror reflecting our grandest ambitions and our most terrifying vulnerabilities. Can we truly evolve enough intellectually and ethically to wield such power without incinerating ourselves in the process? The question isn't just about physics anymore. It's about who we are and who we are destined to become. In the face of ultimate cosmic power, the stars await, but the price of admission might be our very existence. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.